Write the name of the chapter first. It's units and measurement. So what are units? What is measurement? We have been studying measurement and units from lower classes, right? प्राइमरी क्लासेस से हमें पढ़ना सिखाते हैं कि मेजर करो, इसका मेजरमेंट इतना है, इसकी यूनिट इतनी है. सो व्हाट डू यू मीन बाय यूनिट्स एंड मेजरमेंट? बोलो.
हर जगह पे फिक्स कर दिए स्टैंडर्ड यूनिट्स ताकि कोई कंफ्यूजन ना हो.
स्टैंडर्ड यूनिट्स फिक्स कर दिया सो दैट कोई कंफ्यूजन क्रिएट ना हो. एंड व्हाट एल्स?
मेजर करने में आसान.
अच्छा, आपने हैंड स्पैन ऐसा कुछ 6th क्लास में किया था, है ना? क्या करते थे उसमें? आउटलाइन करते थे एंड देन वी मेजर द लेंथ. एक ऐसे ही फुट का भी किया होगा कुछ. तो हम बोलते थे कि नहीं, ये वाली यूनिट्स तो हम ये यूज नहीं कर सकते. एक गिट बोलते हैं ना इसको हिंदी में, है ना? सबके एक गिट अलग अलग आते हैं. तो ये मेजरमेंट जो है ये रिलायबल नहीं है, बिकॉज सबकी साइज डिफरेंट है, राइट? तो 6th क्लास में हमें ये बताना शुरू हो गया था. उसके बाद हम स्केल्स चूज करते हैं. वी हैव डिफरेंट स्केल्स, राइट? फॉर लेंथ we have meter scale, and we know how to convert different units of length, meter into centimeter, kilometer, millimeter, hectometer, decameter, decimeter, right? This we know. Okay, so let us explore some of the questions. Why does the rainbow have specific colors in a specific pattern? This we had just discussed. क्या किया था उसमें कि जो भी whatever we see around us, we can reveal the laws of nature from that thing. Okay, so what is this phenomena called? It's dispersion of light. Why do stars twinkle? It's atmospheric refraction. Very nice. What is a meteoroid? It is an heavenly object. It is a heavenly object which revolves around the sun like planets, but it has, बताओ क्या होता है meteor? heavenly objects होते हैं और फिर when they enter the earth atmosphere, then they start burning. They catch fire due to friction, atmospheric friction. Yes. Why do day and night occur in cyclic order? Because of rotation of earth around the sun, they occur in cyclic order. All this question lead towards curiosity. Now what is this curiosity? And curiosity leads us to science. What is science? Systematic knowledge of the physical or material world gained through observation and experimentation. So we observe certain things, we do experiments, and we come to conclusions. Observation is, as we can observe this figure, and experimentation. See, observation need not be always correct. When we observe a railway track, it doesn't appear to be parallel, but actually the tracks are parallel. Cannot just trust just an observation. Experimentation is essential. So for this, we require precise calculation. For example, in Ohm's law, we can say the ratio of voltage to current may be constant, may not be constant. We need to measure things for accurate results. The purpose of experiment is to establish the laws. Measurement of different physical quantities is extremely important. This leads us to a very important topic, measurement. Let's understand some topics before we start this topic. What are these quantities called in physics? We have different quantities which can be measured. Weight, we can measure the weight of an object, we can measure the length, we can measure height of an object, we can measure the temperature, we can measure pressure, time. So these are called physical quantities. All these are called physical quantities. So what are physical quantities? Physical quantities are those which can be measured, are called physical quantities. Okay, for example, we can measure the length. Length is a physical quantity. Similarly, mass, volume, temperature, area, volume, density, etc. are measurable quantities, and therefore they are called physical quantities. On the other hand, non-physical quantities are those which cannot be measured. The quantity which cannot be measured are called as non-physical quantities. For example, love, hatred, like, etc. You can write this if you want to. Okay, which of the following is not a physical quantity? Length, mass, time, air. Air is not a physical quantity. Which of these is a physical quantity? Acceleration, like, dislike, hatred. Acceleration is a physical quantity because it can be measured. Curiosity leads us to science. So physical quantities, any quantity which can be measured directly or indirectly, in terms of which any laws of physics can be expressed, is called a physical quantity. So there are two types of physical quantities in SI system. Okay. Yes, very good. Fundamental quantities and derived quantities. Fundamental quantities are the basic quantities. And there are 7 fundamental quantities. 7 and 7 plus 2. Okay, supplementary quantities we have. Yes. So there are 7 fundamental quantities and 2 supplementary quantities. And using those fundamental quantities, we can derive the units for other quantities. Okay. They are also called as base quantities. Fundamental quantities are also called as base quantities. So what is a fundamental quantity? A physical quantity which does not depend on any other physical quantity for its measurement is called fundamental physical quantity. It is independent. It does not depend on any other physical quantity. For example, length. Length of any object is independent. Okay. And what about speed? Speed depends on length and time. It depends on distance and time. So it is a derived quantity. Time is independent. So it is fundamental. Temperature, fundamental. Acceleration, derived. So we have 7 fundamental quantities. The first one is length. What is the SI unit of length? Meter. Symbol is small m. What is the SI unit of mass? Kilogram. It's kg. Time. Thermodynamic temperature. Kelvin is the SI unit. The other units of measuring temperature, what are those? Yes. Amount of substance? Mole. Electric current? Ampere. Luminous intensity? Candela? CD. And what is luminous intensity? It is the measure of intensity or brightness of light. Okay. And we have 2 supplementary quantities. We have 2 supplementary quantities. What are those? Plane angle and solid angle. Plane angle is measured in radian, or we can write RAD for plane angle, and solid angle is measured in steradian, or we write SR for steradian. Okay, so plane angle and solid angle are 2 supplementary quantities. So plane angle, you know, what is a plane angle? Plane pe ho. If we draw a circle, then theta is L by R. L is the length of the arc, R is the radius of the circle. So theta is the plane angle. And what is solid angle? What is solid angle? Solid angle is this. Okay. So these are 7 fundamental quantities. Okay. Length, mass, time, temperature, electric current, luminous intensity, and amount of substance. Next, we have supplementary fundamental quantities as we have discussed. Radian and steradian, plane angle and solid angle are the supplementary quantities. Okay. And how do we measure plane angle? You can see, look at this picture. We have a circle. Then this angle theta is the plane angle. This L represents the length of the arc, and this R is the radius of the circle. Then theta is equal to L by R. Okay. And for solid angle, It is the ratio of subtended area on sphere to radius squared. This area, you can see, which we have considered on sphere and radius square, r square, a upon r square. Okay. A unit of measurement of angles equal to about 57.3 degree equivalent to the angle subtended at the center of the circle by an arc equal in length to the radius. Full circle का angle कितना form होता है? 360 degree. 360 degree is equal to 2 pi. 30 degrees is pi by 6. Pi को 180 put करोगे. 180 by 6 is 30. 45 degree is pi by 4. 60 degree is 90 degrees, 180 degree, pi 270 degree, 360 degree, 2 pi. This we have already covered in mathematical physics. How do we convert degrees into minutes and seconds? Conversion we had covered, right? So next we have derived quantity. The physical quantity which is derived from more than one fundamental quantity is called derived physical quantity. For example, area, density, force, acceleration, work, etc. So these are all derived quantities. What is the formula of A square? Area, it is density, mass by volume, force, ma, acceleration, v minus u by t, rate of change of velocity with time, work, force multiplied by displacement. Do you want to write? So some derived quantities, for example, we have velocity. So velocity is displacement upon time. So both displacement and time are fundamental quantities, and velocity depends on these two fundamental quantities. Similarly, acceleration. Acceleration is velocity upon time. This is another derived unit. It is derived from velocity and time. Velocity is also a derived unit. Work is force multiplied by displacement. So these are derived units. A quantity that can be measured is called a physical quantity. The physical quantities which are expressed in terms of more than one fundamental quantities are called derived physical quantities. Very nice. Derived quantities are which can be expressed in terms of more than one fundamental quantities. For example, area, density, force, acceleration, these are all derived quantities. There are dash fundamental quantities, 7. Okay, these are the 7 fundamental quantities that we have already discussed. Acceleration is derived physical quantity which depends on how many fundamental quantities? 2. What are those? 2 fundamental quantities. Velocity is not a fundamental quantity. Yes. Acceleration is velocity upon time and velocity is displacement upon time. So we can write for velocity, we will write displacement upon time. So what will we get? Displacement upon time square. So it depends upon 2 fundamental quantities, and those 2 fundamental quantities are displacement and time. It's not velocity because velocity itself is a derived quantity. Okay, please write this. Charge is a dash quantity.
Derived.
It is a derived quantity. Derived from? How are they related?
Current equals to charge per time.
Current is charge upon time. So charge is, yes, charge is current into time. Current is a fundamental quantity, time is also a fundamental quantity. Okay. So charge is a derived quantity. Okay, one more question. Is charge a scalar quantity or a vector quantity? Why scalar?
Direction.
डायरेक्शन को भी डिपेंड करता
Direction पे depend नहीं करता, but current is current a scalar quantity or a vector quantity?
स्केलर स्केलर
Who is saying scalar and who is saying vector, please?
स्केलर
Scalar का 1 वोट, vector के कितने वोट है? My God. Current is a scalar quantity. It is not a vector quantity. See, it has direction, but it cannot be added using vector law of addition. Okay? Simple algebraic addition से हम current को add करते हैं. उसमें vector law of addition नहीं लगता है. ठीक है? It is a scalar quantity. All right. So units. Please write the heading units. हर किसी की जिसकी डायरेक्शन हो वो वेक्टर क्वांटिटी होगा ये जरूरी नहीं है. ठीक है, हमें देखना है उसको, अंडरस्टैंड करना. ओके, units, measurable quantity is a physical quantity, we know. For example, mass, length, time, area, force, pressure, these quantities can be measured, so they are physical quantities. A physical quantity is consists of a magnitude and a unit. For example, if I say that length of this particular article is 10 centimeter, so 10 is the magnitude and centimeter is the unit. Okay, 10 is the magnitude and centimeter is the unit. For example, distance is 25 kilometers, then this actually means distance is 25 times magnification of 1 kilometer. Magnification of 1 kilometer means we are magnifying this 1 kilometer 25 times. If this 1 kilometer is this much, then 25 kilometer will be its 25 times. Okay. So if this is 1 kilometer, then if we add 1 kilometer 25 times, then we get 25 kilometers. Okay. So this 25 is the magnitude. Magnitude is the measure of magnification of unit. And you want to write? And kilometer is the unit. Okay. Unit is a standard reference which is used for measurement of a physical quantity. Measurement of any quantity involves comparison with a basic arbitrarily chosen internationally accepted reference standard called unit. The units for the fundamental quantities are called fundamental units, and the units of all other physical quantities can be expressed as combination of the fundamental units are called derived units. For example, meter is a fundamental unit, second is a fundamental unit, but meter per second is a derived unit. Okay. In some wrong ways, units were considered where physical quantities used to be measured. Length was measured with the help of a hand. We had already discussed, but all hands are slightly of different sizes. So it is not a reliable unit. Okay. And what is this? Yes. But what if a very short and a very tall person walks? Then yes. So 1 league is distance covered in an hour by walking. So the units should have certain characteristics. Magnitude or unit of a physical quantity में क्या relation होता है? Magnitude, the numerical value obtained on measuring a physical quantity is inversely proportional to its unit. Yes? So N1 U1 is equal to N2 U2. N1 N2 are the numerical values and U1 U2 are the units of same physical quantity in different systems. Different systems means we have different systems like CGS system, MKS system. So 1 meter is 100 centimeter, right? So meter is one system. Meter comes under MKS system and centimeter comes under CGS system. So when we have 1 meter, then N1 is 1 and N2 is 100. Yes, but when the scientists used to meet internationally, they had a problem with different styles of different system of units. Then they finally came to a conclusion by General Conference on Weights and Measures in 1971 for international usage in scientific technical, industrial, and commercial work at France. They introduced an international system of units called System Internationally the Units, SI units. So we have this system of units, this we have discussed, and SI system is the system contains 7 fundamental units and 2 supplementary units, and these units are internationally accepted. Okay, these units are internationally accepted. Have you read about scientific names of different things? For example, frog is called Rana tigrina, mango is Mangifera indica. Scientific names you don't know? Homo sapiens.
Peatland.
For,
Titan.
Why do we use scientific names, and what is the need of using scientific names? Because in different language, we have different words, right? For mango, in English it is mango, in Hindi it is aam, in Punjabi it is amb. So we have different words, right? So for better understanding, for clarity, for communication purposes, on international basis, we prefer to use scientific names. They are internationally accepted. So whatever language you are using, scientific names remains the same. There will be no change in scientific names. In the same way, see, in India, as we measure distance in kilometers, and in US, it is measured in miles. So we use different units, right? But that can create confusion, and therefore we have created a system of units which is internationally accepted, and those units are called SI units. Okay, so SI units are internationally accepted. So they are rationalized, modified MKS system. See, SI units are coherent. This is important. SI units are coherent. Derived units are obtained without introducing numerical factors. Second, it is rational. Rational means one unit is assigned for a particular physical quantity. For example, joule is used for all kinds of energy. We do not have separate units for different energies, right? For whether it is heat energy, mechanical energy, sound energy, work, kinetic energy, potential energy. So everywhere we have the same unit joule. For all kinds of energy, we have the unit joule. So it is rational. It is absolute. Absolute means there are no gravitational units. Gravitational units होती हैं जैसे 1 किलोग्राम F आपने पढ़ा होगा 9.8 न्यूटन्स, तो वो ग्रेविटेशनल यूनिट है. तो यहाँ पे SI system में we have no gravitational units. Metric, SI system is metric means powers of 10. So we have just powers of 10 here. 1 meter is 100 centimeter. 1 kilometer is 1000 meters. So in powers of 10, we can easily convert one unit into another unit. So convergence is easy. They are absolute. They are rational. They are coherent. Okay. So these are the properties of SI system. Okay. Should I move to the next slide? SI system is invariable. So invariability is one of the properties of SI system. It can SI system cannot be varied, fixed scale. It has a fixed scale, cannot be changed. For example, measuring length between hand and elbow is variable. That's a variable measurement. But SI systems are invariable. Invariable means they have a constant fixed value. Second, availability. SI system is easily available. It is easily made accessible. Okay, which of the following is a characteristic of unit? The unit must be universally accepted. It must be invariable and well-defined. Yes. A standard unit is necessary for the sake of accuracy, convenience, uniformity, equal justice to all.